In this video, I'm going to show you how to find vector components. So concept zero, this is what vector components are. If you've got this vector here, which is a displacement vector that's 36.869 degrees above horizontal, and it's 5 centimeters long, the components are that part of the vector that lie in the x direction, okay, and that part of the vector that lie in the y direction. So this vector is to the right and up. Okay, so this is the x component, right? And this is the y component. Okay, now I'm assuming you're all good mathematicians, that you understand that this is the y-axis, right? This is the x-axis there. Okay, now let's suppose that we did a little math here and we realize that this thing is 4 centimeters long, and it is 4 centimeters long. If you pick that angle there, this will be 4 centimeters long, and this is 3 centimeters long. This is in the positive x direction, that's in the positive y direction. And so A, we would write it this way. We would say 4 centimeters x hat plus 3 centimeters y hat. This is what we do. We just put these little hats, or like little carrots on top of there. That means 4 centimeters in the x direction plus 3 centimeters in the y direction, right? Now don't be silly and add 4 and 3 and say, well, that's 7. It's longer than the hypotenuse. That's the way these things always work. It's that 4 squared plus 3 squared is 5 squared, right? This is a 3, 4, 5 right triangle, and it would have that particular angle right there. So this, when I say component notation, or vector component notation, this is what I mean specifically, okay? It always looks exactly like this and no other way. You have the x component first, y component second. You say something units x direction, or x hat, right, plus 3, whatever, something units y hat, okay? Now I'm going to show you how to figure these out, how to figure out what those components are. We're going to use sine and cosine, and we're going to use SOHCAHTOA, okay? So let's suppose that we've got this 12 meters and it's 27 degrees above the negative x-axis there, okay? The first thing to do is to draw the components. This is surprisingly difficult, but look how straight a line I can draw, right? Notice that that x component is negative. It's to the left, but the y component here is positive. Okay, so when you do these, they need to be arrows, just like this. Okay, start at the tail, go to the tip. Okay. The second thing is to realize that one of these sides is adjacent to the angle, that is, it touches the angle, and one of the sides is opposite the angle. It's like a toothpick in the mouth of the angle, as it were. Okay? And the way this works is that the adjacent, you get the adjacent by going magnitude, which is 12 meters times the cosine of the angle, and the opposite side you get from magnitude sine of the angle. This is from SOHCAHTOA that you learned in trigonometry, I do believe. Okay? So to find the adjacent side, okay, the adjacent side here is 12 meters cos 27. Okay, so let's bust that out. I'm going to take my calculator now, and I'm going to make sure that it's in degrees. So I'm hitting the mode button. Degrees is highlighted. I'm good. Okay, so 12 cos 27 is 10.69. And this is meters, because that's meters, right? That's meters, this is degrees, right? Okay, and then the opposite side, I expect the opposite side to not be quite as long, because that's a small angle there, right? It's less than 45 degrees, so therefore it is an adorable angle, right? So 12 meters sine 27 degrees, okay? So 12 sine 27 is 5.45. Okay, so that's the second step, is you find the adjacent and the opposite side. And now we got to decide plus and minus x and y, right? So this thing's going to look like something meters in the x direction plus something meters in the y direction. We got to decide which one's which. This is clearly, the opposite side is up and down, so that's our y. It's in the positive direction, so it's positive plus, I'm not going to say plus a positive, I'm just going to say plus 5.45 meters in the y direction, right? This side is the adjacent side, there is the x direction, but notice that it's to the left, so we're going to make that negative 10.69. Okay, so when I say decide plus and minus, decide is it in the plus x or minus y? That's easy. Left is minus for x, right is plus for x. Plus up and down, up is plus for y, and down is minus for y. Okay? Now we're all done. This is our answer here. Okay? Our answers always look like that. It's something units x direction plus something units y direction. Always put your x first, always put your y last. Okay? If the y happens to be negative, it's traditional to say plus a negative. It's weird. Let's do another one. Are we ready for this? Here's another example, and I'm going to just bust out a whole bunch of examples here. Okay, so step one, draw the components. Notice that the components, you start at the tail, you go to the tip. Ooh, I did that one pretty well, didn't I? Okay, so there are my components, okay? This side is the adjacent side because it touches it. This is the opposite side, okay? The adjacent side is hypotenuse, so 23 meters per second. Cos, this is always true, 31 degrees is that angle there. Okay, so A is 23, cos 31. It's 19.71. Okay, the opposite side is 23 times sine of 31 degrees. So 23 sine 31. That's 11.85. Okay, so now we've got to do something, and this is meters per second now, right? Meters per second in the x direction plus something meters per second in the y direction. Okay, so now we're on this step. This is the key step here. This is the hardest step. Decide x and y. Let's see, opposite side, that's our x, isn't it? Because it's left to right. So 11.85, and it's to the left, so it's negative. So I'm going to say negative 11.85 meters per second x, right? And now we've got the y direction. This adjacent side is our y direction, okay? And so I'm going to say 19.71, and it's up, so it's positive. So positive 19.71. Now that's a little beyond the pale to say plus a positive, right? We don't really need that there, okay? So notice that this is the hardest thing. This is what everybody messes up. Everybody can do this, but then you've got to figure out, okay, that's to the left. This thing goes to the left. This thing goes up, okay? So the upward one is the positive y. To the left is negative x. Okay, our answer looks like this. Now we can double check this. This looks like this side should be longer than this side, and it is, right? And it looks like this side should be negative, and it is. And I think we're good, right? The final thing that I'll leave you with is, if you recall in math class, the quadrants, okay? This has a positive x and a positive y. This has negative x, positive y, right? If you remember ordered pairs. This is negative x, negative y. And this is positive x, negative y. Okay? This one, since it lies in this quadrant here, this vector looks like this. Okay? Since it lies in this quadrant, if you put the tail at the origin, it's got a negative x component, a positive y component. Okay? I'll do more examples. Do as many examples as you need to be confident about doing this. This is the hardest vector skill